Hi guys, welcome back to part 2 of fractions. Just as a little recap, in part 1 we discussed the different types of fractions, and in this video we're going to be using those different types of fractions to add them, subtract, multiply, and divide. In addition, it's really important that the denominator is the same. If you're not really sure what denominator and numerator are, then here's a chance to find out. So if you have a number 4/5, the top number is always your numerator, and it's the bottom number that is always the denominator. So whenever I refer to numerator, I mean the top number, and whenever I refer to denominator, I mean the bottom number. And I'll be using these two terms quite a lot in addition, subtraction, multiplication, and division. So make sure that you know which one's the numerator and which one's the denominator, otherwise you can easily get confused. So we've said that the denominator needs to be the same. Now let's look at an example. I'm gonna have a quarter add 2/4. Okay, now the denominator is the same, and all you really need to do is add the two numbers on the top, so the numerator, so 1 add 2, and that gives us 3, and the denominator stays the same, so you get 3/4. Now why does the denominator need to be the same? Let's have a look at an example. So if I have a square which is divided into 4 and I shade a quarter of it in, but then I want to shade 2 more. So I shade 2 more. So now that is 3/4 shaded, which is what I've got here. So that's why the denominator needs to be the same. Because if this is split into 7th, it'd be 2/7, but this one is out of 4, so it will be really hard. That's why you need to make sure that the denominator is the same, and then you add the two numerators together. Here's another example, but in this case the denominators are not the same, and you can't really add them straight away unless you can do it in your head, but I'm not a genius, I can't do it in my head, so I'm going to do it the long way, which is what I suggest you guys do as well, because in the exam you always get carry-on marks, which means that you have to show your method to get all the marks. So step number 1 is to find the common denominator. The way you do that is by finding LCM of these two numbers. If you're not quite sure how to find the LCM of any two numbers, then I suggest that you go back and look at my video on LCM, because that explains every single step that you need to know for finding LCM. If you're not really sure and if you continue watching this video, you are going to be lost. So I will post a link below and make sure that you click on it and watch it. So let's come back to addition of fractions. 5 and 20. Now you can write the times table of 5 out and then write the times table of 20, find the common number, and the one that is the lowest will be the lowest common multiple. Or you can clearly see, for me it's really obvious that the LCM is going to be 20, because 5 goes into 20 4 times. So we know the LCM is 20. Step number 2 is that we need to make sure that we write this down. So we need to make sure that we write down 20 and we write down a big line here above 20. So 1/20 stays 1/20 because it's already got 20 as the denominator, but it's a 2/5 that we need to work on. So 2/5. Now I need to multiply this to something, so I get something out of 20. Okay, I know 4 times 5 gives me 20, so I can write down 4 here, but I also need to multiply the top by 4. Now the reason why I multiply the top by 4 is because essentially 4 divided by 4 is same as 1, and you know any number multiplied by 1 gives the same number. Now the reason why this works is because, let's take a look at an example. I think that everything just makes so much more sense with a diagram, so that's what I'm going to use now. So they're meant to be like completely identical squares, okay? It's not to scale, but they're meant to be. So in this case, we can clearly see that is 1 out of 4 that's shaded. But in this case, it's 2 out of 8 that's shaded. However, because they're meant to be identical squares, we can quite tell that this is same as this area. So we know in fact a quarter is same as 2 over 8, but obviously they're not the same numbers, but the fraction is still the same. So that's why this works here, because 2 out of 5 is same as 8 out of 20. Okay, so after having multiplied 2 over 5 by 4 to give 8 out of 20, all you need to do is write the 8 here because it's 8 out of 20, and then add 1 over 20. Now, the reason I told you guys to write 20 and then a big line above it is because the denominator doesn't change. So you don't add 5 and 20 together. You only find the common denominator, write it down, and it's the two numbers, so the numerators that you add. So 8 add 1 gives us 9. So the final answer is 9 over 20. Subtraction works in a really similar way to addition, because in subtraction as well, we want the denominators to be the same. But in this case, we can see, okay, the denominators are already the same. They're both 10. So we write down 10, then we make a big line above it, and we write down the numerators just as it is. So it's 9 minus 1, which then gives us 8. And the denominator stays the same, so it's 8 out of 10. Now, I'll show you through a diagram why we want the denominator to be the same and why the top numbers just are written down as it is above the 10. So if we have 9 out of 10, so there are 10 rectangles and we're shading 9 of these, but we're taking away 1 out of 10. We've got 10, but we're taking away 1. Now that leaves us with 8, which is what we've got here. So that was for denominators that are already same. However, we can easily have two fractions that we need to subtract, which don't already have the same denominator. So in this case, what we need to do is circle the denominators and find the LCM of 7 and 3. But we know that 7 and 3 are prime numbers, so the LCM is just going to be 21, because 7 times 3 gives us 21. This only works for numbers that are prime. So if two numbers are prime, the LCM will just be those two numbers multiplied together, which in this case is 21. So let's write down 5 over 7 first. So we need to multiply 5 over 7 by a number that gives us something over 21. And we know it's 3, so we need to multiply the top by 3 as well, and we get 3 times 5, which is 15. And now we need to do the same for a third. So we need to multiply a third by something to get us something out of 21. So we times it by 7, top and bottom. So 7 times 1 gives us 7, and then 7 times 3 gives us 21. So 5 over 7 is same as 15 over 21, minus, because of the minus here, a third, which is same as 7 over 21. Now we can see that the denominators are the same. So denominator, big line above it, and then do as it says on the top. So 15 minus 7, which is 8 out of 21. So the final answer is 8 over 21. Multiplication is a lot easier than addition and subtraction, because if you have two fractions, you don't need to find the common denominator. All you do is multiply the two top numbers and multiply the two bottom numbers. So 2 times 4 gives us 8, 3 times 5 gives us 15, and we just leave it at that, unless the fraction can cancel down. But in this case, the fraction can't cancel down any further, so we just leave it as this. Let's look at another example. So we can have 2 over 8 times by 3 over 4. So it will be 3 times 2, which is 6, and 8 times 4, which is 32. This can cancel down, and it can cancel down to 3 over 16. When you're multiplying two fractions together and the two fractions are quite small, so anything like over 20 times by a half, you can just multiply the top two numbers together and multiply the bottom two numbers together and then simplify it. So 8 over 40 will simplify to a fifth. That's very simple. 8 and 40, very easy to simplify. However, sometimes you can get numbers that are not quite so easy to simplify at the end. I mean, it's not impossible, but it's just you'll get a really large number. So I'll show you a trick to make life a lot easier. So let's say we've got something like this. The little rule is that you can divide any top. By divide, I mean you can simplify any top and any bottom. So you can simplify 64 and 68 together, or 64 and 100, or 50 and 100, or 50 and 68. So in this case, I'm going to simplify 50 and 100 together, because I know 50 times 1 gives us 50, and 50 times 2 gives us 100. So 50 over 100 is basically a half. So this becomes a 1, this becomes 2, because 50 over 100 is same as half, okay? And 64 and 68, I know both go in the times table of 4, and I know 16 times 4 gives me 64, and it's 17 times 4, which gives me 68, okay? Now I said any top with any bottom. We've still got 16 and 2. 2's at the bottom, 16's at the top. So I know 16 and 2 can cancel down further. So 16 can cancel down to 8. 2 can cancel down to 1. So the final answer is 8 times 1, which is just 8. And 1 times 17, which is just 17. And the answer you get is already cancelled down. Do you see what I mean by when I say that? If you multiply the two top numbers together and the bottom two numbers together, you would have got a huge number, and then it would have taken you ages to cancel it down to get to 8 over 17. So it's a lot easier to cancel it down before you multiply it. So if in any case you feel like you can cancel it down before multiplying, please do. Division is very similar to multiplication. The only difference is that it's just got one extra step, but that step is very simple. So first fraction, you write it down as it is. You change the division sign into a multiplication sign, and you flip the second fraction. So 1 over 2 will flip to 2 over 1, and then you just do as you would normally do for multiplication. So 4 times 2 to give you 8, 7 times 1 to give you 7, and that's your final answer. So for 7/9 divided by a third, what you would do is write the first fraction as it is, so 7/9, change the sign into a multiplication sign and flip the fraction around. So 1/3 will flip to 3/1. Okay? You can multiply the top numbers together and then all over the bottom numbers multiplied together, or you can cancel it down and then multiply it. I can see two numbers that can cancel down, and that is 3 and 9. They both go in the times table of 3. So 3 times 1 gives us 3, and 3 times 3 gives us 9. So 7 times 1 to give us 7, and 3 times 1 to give us 3. And that is the simplified version. So 7/9 divided by a third is same as 7/3. So here's my top tip of the day, and that is when you're doing either addition, subtraction, multiplication, or division, with proper and improper, it's not really a problem because they're already as fractions that we can work with. So proper is something like 4/5, and that's very, very easy to work with, whether it's addition, subtraction, multiplication, or division. It's fine. Improper is also fine because that means it's top heavy, so we can have something like 9/8, which is also fine to work with. But mixed, which is something like 2 and a third. You can't add, subtract, multiply, or divide with this, so you're going to have to convert this fraction to improper to be able to add, subtract, multiply, or divide.